Hello, everyone. My name is Mauro Nievas Ofidani, and I'm a medical doctor and a data scientist. Today, we will talk about the MultiCaRe Dataset, a multimodal case report dataset of clinical cases, images, labels, and captions. I will describe the contents of the dataset, I will show you how it was created, and also I will explain you what is the best way to use it. Okay, so let's start. MultiCaRe is a dataset of clinical cases. It includes cases from different types of medical specialties, such as oncology, surgery, cardiology, or any specialty that you may find useful. MultiCaRe is multimodal. It includes different case report articles and their metadata, including mesh terms, citation information, license type. It also contains the text data from the actual clinical cases, and it contains also images related to those cases and image captions and image labels. The structure of the dataset is such to make the use of the dataset as easy as possible, so that you can use it to train language models, computer vision models, or multimodal models. MultiCaRe is open access. The dataset is available on Zenodo and also on Hugging Face. Also, we have published, together with Professor Del Rios, a data article in Data in Brief that you can access. And there is also a public GitHub repository where you will find many useful resources if you want to use this dataset. Okay, let's talk about some numbers related to MultiCaRe. It contains more than 75,000 case report articles from 1990 until last year. These articles were written by 380,000 authors, and they refer to 96,000 patients. The dataset contains 135,000 images, and in total it sums up 8.8 gigabytes in size. Okay, here you can have a better idea of the kind of patients that were included. On your left, you can see the population pyramid with the distribution of the patients in terms of age group and gender. The mean age of the patients is 41.5 years. 48.5% of the patients are female and 51.5% are male. In this slide, you can see the type of images that you can find in this dataset. It's virtually any type of medical image. Below each image, you will find the corresponding labels. So you can see CT scans, ultrasounds, X-rays, mammographies, also images related to pathology, and also electrocardiograms, endoscopies. There's virtually any type of image. And the labels related to them are referred to the image type, but there are also more granular labels with information about the image technique, such as Doppler or with contrast, without contrast. Also, there are labels related to anatomical information, such as the type of view, axial, or also the anatomical part of the body, or the laterality. And there are also labels related to findings, to clinical findings that are shown in the images. One important thing to mention about this dataset is that a dataset of clinical cases is not the same as a dataset of medical records. There are some key differences between these two types of datasets. Then the first difference that I'm going to mention is about the distribution of the clinical cases of the clinical presentations. In a clinical case dataset, normal cases are underrepresented, and real clinical presentations are overrepresented in comparison to medical records. And in my opinion, this is something positive because this makes clinical case data sets, this makes them richer with more variety. Regarding the text extension, clinical cases are shorter than medical records. Usually they don't include irrelevant information such as the patient denies pain. These kinds of mentions are very frequent in medical records, but they are not mentioned in clinical cases. The quality of the text, in medical records, the quality is high, but in clinical cases, it's even higher because the text is written by doctors, then it's reviewed, then it's published by some journal, so the text quality is higher. In clinical cases, as they are intended to be published publicly, there is no PHI present. And one last difference is regarding images. They tend to be much smaller in clinical cases than in medical records. Okay, so now let's talk about how this dataset was created. The first step was to find the open access case report articles in PubMed Central. Then we extracted both the metadata and the contents of these articles. Inside the content, we identified the parts of the text that mentioned clinical cases, and we assigned those cases to the patients, to each patient. So if there were, sometimes there was more than one patient, so we had to split the text into multiple parts. And then we also extracted demographic information based on the text from clinical cases. By using regex, we extracted mentions of age and gender, and then we normalized those extractions. We did all this using the resources that you can see below. We used BioC API from PubMed Central, Biopython requests, and Beautiful Soup. Then we did some image preprocessing. The most important task that we did here was to split images. In case report articles, it's relatively frequent to see compound images like the one on the left, where the same file has more than one image. So what we did here in order to split it, first we did some edge detection, and then we identify the limits of each image by considering the parts of the image that were not crossed by any edge. And that's how we ended up splitting images into multiple parts. In this part of the process, we used Europe PMC's API to download the images, and then we used OpenCV to do the preprocessing. We also did this kind of process in order to remove any border that could be present in images. And one more thing that we did when creating this dataset was to create image labels based on the contents of the captions. So first of all, if there was a compound caption that corresponding to a compound image, we had to split it. So here you can see an example. The input caption is brain CT scan. There is a mass in the frontal lobe A and a hemorrhage in the right temporal lobe B. So first we had to split this caption into two. As you can notice here, some part of the caption was included in all the subparts, and then one part of it is A, assigned to A, and then the other part of it is assigned to B. Then what we did was to extract the relevant parts of the text. Here we used contextual parsers from JSS library, together with some dictionaries that we created to extract this information. So you can see brain was extracted as site, CT scan was extracted as imaging test, mass was extracted as imaging finding, and frontal lobe was extracted as site also. Here there was no, we didn't need to use any assertion model or any relation model because of the type of data that we were dealing with. Captions usually are descriptions of the images, so you will not find, I don't know, hypothetical mentions or absent mentions. So these kinds of contextual parsers alone were enough. And then we normalize these extractions by using some dictionaries that we created. So any extraction that referred to CT scan, for example, was extracted as was assigned the label CT. Any brain or frontal lobe, they were both assigned brain, for example, as a final normalized label. Okay, so now let's go on with the demo. I will show you some examples now. You can find more examples and more details of everything in our GitHub repo. As you can see, there is one folder with notebooks that explain how the dataset was created with more detail. Then there is a folder with demos. There is first an extended demo, the same that I will show you after this, but much more extended with much more detail. And there is also a demo in case anyone who doesn't know how to code, in case they want to create a case series, they will find a notebook there. So this is a link to the repo. Okay, in order to make the best use of this dataset, you will need to create a subset based on your use case. For this, you will see that it's very simple. You will only need to follow four steps. The first step is to clone the GitHub repo in order to be able to import the MedicalDatasetCreator class. Then you have to download the full MultiCaRe dataset. To do this, you have to instantiate the MedicalDatasetCreator, and you can define any directory that you want. By default, it is medical datasets. This step here takes from 5 to 10 minutes. So you have to have a little patience, but you only have to do this once. If you want to create 10 subsets, for example, you only have to do this once, and the rest of the process is much quicker. Then the third step is to define filters, depending on your use case. There are different types of filters. They are explained in detail in the repo. So you have filters related to metadata, like the minimum year of the article, or maximum year, or the type of license, or the mesh terms also. There are filters related to the demographic information, like minimum age or gender. There are also filters related to the content of the clinical cases, also to the image labels, and to the contents of the captions. In this example, there are 4 filters were applied. So this means that patients with a minimum age of 18 were filtered in. Then only male patients are included in the dataset. Then the third filter is to filter in cases with captions that include words like metastasis, tumor, or mass. And the last filter is to filter in cases with captions that include normalized extractions such as MRI or brain. So once you have defined your filters, you just have to create your subset by using the create dataset method. So you provide a dataset, a name to the subset. In this case, it is male brain tumor dataset. Then you provide the filters that you have defined, and at the end, you also define, you select one type of dataset. It can either be text, if you only want the text of the clinical cases, image, if you only are interested in the images. Apart from those data, you will get like the metadata that may be useful in your case. It can also be multimodal if you want both text and image and the metadata. And case series, it's also multimodal, it's also text and image, but it's the way the data is organized is different because you have one folder per patient. In this case series, it's not intended for model training. This is intended more for medical doctors who are interested in creating case series. Okay, so here we have an example of one case. Of some of the data that refers to one case. Cases have a case ID, gender, age. You can see here also the clinical case. A 32-year-old male presented with a history of intermittent headache and so on. This is the full case. Then you can see one of the images and its labels like MRI, contrast, brain, and so on, and the citation information, which includes PMC ID, the year, the authors, the license. This is CC by NC. Okay, so that's all for now. I will stay some more minutes if you have any questions. You can connect through LinkedIn if you want. Please feel free. We're planning to release a second version of the dataset like in the next few months. So any feedback that you may have is more than welcome. Okay, and thank you all for your attention.